Okay, welcome. Let's do a small example here of very basic black box testing. I'm going to try to keep it to black box testing thinking. Of course, it's not always clear cut like that. And I'm going to do this in Julia, so but get the logic of it rather than the exact syntactic details. I'll try to go a bit quick, but you can go through it slowly on the video. Here we're going to write test cases for something called vecmin, and we have an implementation, but we're not going to look at that because we want to do black box testing here. So we're going to go more from our understanding about the requirements. And vecmin is a function, and it takes a vector, so that's the vec, and min means return the minimum value of a vector of floats. Of course, this is already available in any programming language, but that's not the point, right? So we have our own implementation here, just as an example, and we're going to write tests. So I'm going to open a code editor or an editor, um, and let's see if we have a okay size here. I'm going to do this very basic, so I'm not going to use an IDE or anything like that that can confuse you. Going to keep it simple. We can maybe even go, no, where's that? Full screen. Anyway, let's skip that for now. Okay, in Julia, if we want to do testing, we will want to, let's do this a little bit bigger. Maybe it looks strange, but anyway, we will want to include the test lib or package, which is available in basic Julia, so we don't need to do anything in particular. We just include that, and the basic thing we get is the macro test, which takes then where we can write a logical expression and we can compare things like, well, here we're comparing the value 1 to itself, so that should be true, right? But the point is that we can then compare actual values we get from calling vecmin later and compare that to our expectations. So let's start here, Julia REPL. So this is just Julia, never mind. I mean, this is just REPL, so you can write code and it will execute that. And so let's include the test package. No, it's going to be a little bit slow because Julia is just in time compiled. So let's run this. So it's now compiling the whole package and macro and whatnot. And we get test passed, which is good, right? If we had said is 1 equal to 2, then we get a test failed, and it's now compiling lots of code. So next time it will be faster. So now it's super fast. So test 1 equals 2 is of course giving us a failure, and it writes where did it find this? Well, now it was not part of a file, so it's REPL row 6. Anyway, the expression was 1 equals 2 and it evaluated to 1 equals 2. So this is good. This reporting is good. If we instead had a value, let's say the actual value was 1 and we expected A to equal 2, right? Then you see the value of this. Oh, okay. And you see, this is the beauty of doing it live. So if we test that the variable actual is equal to 2, we get test fail, which is good. The expression was, this is the expression that we wrote, the condition here. It should be true, is actual should be equal to, but it evaluated to 1 equals 2, which is obviously false. So there was an error during testing. Of course, sometimes we want to check that there is an exception thrown, and then we have another macro, I think it's like this, test throws error. Can we do it like this maybe? Actual equals to error. So what kind of error do we get? there was an error, so I'm not sure. Let's say if we write an exception here. Test, okay, throws exception, throws error. I'm not sure what do we get when we do an error. Okay, anyway, we can check for specific errors with the test throws macro. So let's start to do some testing then. Now you know the basics. I mean, this is what every JXUnit testing library gives you. Another macro is we can group things into a set. So this would be how you would use a test case. You would write a test case like this. Like to work main basic test case. Okay, it's not a good name, but this is how you would write it in Julia. So we have a test set now, and here you can have multiple checks, tests within one specific test case, or you can collect multiple test cases in one set like this. So you know it's very flexible, the Julia testing library. So okay, let's start testing then. So we're going to call vecmin with, say, very simple here. So we're doing black box. So we're going to give it arrays, and we want to check that it performs correctly. And we only have the requirements in our head. So the minimum of a vector, if we give it a vector or an array like this with the values 1 and 2, it should be 1, right? This is what we want from a black box perspective. So the thinking I'm doing is I'm starting with something very simple to get going. So if we run that, oh, we get an exception. What do we get? Vecmin is not defined. Right, we forgot to include the implementation. So vecmin implementation. We have to read the code in, right? Okay, now we have it. So let's run it again. Oh, it throws a method error. No method matching vector min array of integers. Oh, okay. Yeah, I said it's going to be vecmin is going to be implemented for floats, right? So I'm giving it integers. So now then we can check that vecmin, let's say this is the behavior we want. So we want it to throw an error, throws method error. So now we can say the vecmin should throw a method error when we call it with integers. Right, okay, so now we passed the test, right? So it's now correct that it throws a method error, which is what we say we are expecting here when we call it with integers. Okay, so that was the first test case. We're just grouping them since it's such a small example here. So let's now do it right. So we're going to send in floats instead. And now we want it to return the float. So hopefully this passes. Wow, that's great. So that was the basic one. What more? Okay, so in this one we had the minimum value was the first one. So obviously we want to test something where it's the last one, and here what I would probably do here is to change the values at the same time. So the main purpose of the next test case, this one, is going to be to have the smallest value last, but I'm going to change the values just because then I'm also testing that it can work for floats that are not close to integers, right? So let's do this. Oh, and it passes. Great. What more? What more? Well, maybe now we had the minimum value first and last. So let's put it in the middle of a longer one. So let's basically add 3.14. Should still be 1.9 here. And I'll probably change that too to do something else. 1.62. To change it around a little bit, all right? We want the test cases to be diverse. We don't want them to be the same. So let's do, well, maybe we should keep it smaller here than the last one, but anyway, it doesn't matter. Let's do that. It should still be 1.62. It's okay. What more? We're thinking about values. So maybe now we've had positive ones. Let's do one on the boundary to the negative ones. So let's say we do 0 here. We simplify it. 0.0. That is still the minimum value. That's okay. What more? Maybe putting in a negative one. So let's keep the 0. Let's add a negative one on the end. So now that should be the small one, right? Okay, we're still going black box. We're not thinking about the code, how it's implemented. We're thinking about the interface and common, so far, use cases, right? What more? Okay, we've tried now with fairly small values, so for sure we need to go much bigger. Let's do like 1.4 times 10 to 2. So yeah, let's do something bigger yet. 7.6 to 5. I don't know, so maybe 7.8 to 6. Okay, so we are expecting the minimum to be the first one actually, right? Here maybe we want to get fancy. No, let's keep it like that. So that was big, but it was still not so big, right? Let's do something very big. I don't know. Let's do 22 here, and I don't know, 23 here, and this one we don't care about anymore. We just want to test something. It should be 22 is the smallest, right? Okay, so now, oh, test failed. What is this? Right. Expression, blah, 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 evaluated to, okay, so the minimum is 10 to 10. Okay, so that must be something super strange with this implementation, right? That is not what we want. But we are just the testers here. We are not going to go into and look at the code. At this point, we would tell the developer, or we would go in if we were the developer and fix it ourselves, right? But for now, we have a few test cases. Let's run the whole suite. We copy in the whole test set with all the stuff we've done, and we get some kind of nice report. Okay, something failed. We knew that. Then we get the summary in the end. It's faster now when it's compiled. 7 passed checks and 1 failed for a total of 8, right? So this is also typically what you get from these kind of systems. So we now know that we have a failure here. So, there are support in this test library to skip things, and sort of while you're talking to the developers, you can sort of skip this one. But now we just comment it out for now, right? But we know that it should be in there, and we need to go to check that with someone. What more? Maybe we should do a big one with also negative values. So if we do minus 1.4 to the 10th, or let's say we do the 8th here. And here we do minus 4.56 e to 15, then it should be this one. That is the smallest. So we have tested also a negative one, right? And this seems fine. So, okay, so you can handle small values, but not very big ones. So that seems to be an error then in the implementation. Okay, so far, what have we done? We've gone through sort of very common situations. We have done small stuff, but we've only varied basically the values, right? So let's add a few test cases where we look at the length of the vector. So for example, well, I mean, if you have a value of 0, that seems fine. And, here we could go for random testing. That would be very cool, right? We could just do 100 times, say. a loop 100 times, and we first get a random number. Do we have rand, or do we need? Yeah, we have rand. So in Julia, you can get a random number between, say, 0 and 100,000. You don't need to have the underscore, but it's just to make it easier to write like that. Then you get random numbers. So let's say number equals random. I don't know what we can. Maybe we could go. Yeah, we can go positive first, I guess. Positive number is random from 1 to, let's do 1 million. Right, and then we test that if we apply vecmean on a vector where we have a positive number, which here was actually an integer. That wasn't so smart, right? Let's go. We take, we start from we take a random value from the range that starts from the float 1 and goes to float I don't know, 10 million, and it goes in steps of 0.5. So we can take only these. We can do maybe this. This is fine, I guess. Oh, okay, I should have cleared that. So get us a positive number in this range. That is fine. Then if we get the positive number like this, then it should be equal to the positive number, right? I mean, this is a way to do random testing. We randomly generate a test case and we check that this is always true. If we take vecmean on a vector having one positive number, we should get back the positive number, right? So if we run this 100 times, okay, then we've done a lot of testing. So this loop will now do random testing of vecmean 100 times. We have 1, 2, how many do we have? We have in this test set we have 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 100. So if we run the whole test suite now, we should have 100 plus 9. Okay, so we have now 109 checks or test cases, if you want, out of and all of them pass. And we can check again if we add this one back in and we run the whole thing again. We should get 109 pass and 1 fail then, right? Okay, that seems good. So the length of the vector, now we have a loop, so we can reuse that. Let's do, yeah, we can do something, another random test here. We haven't talked about random testing, but it's so easy to do at this point. So if we do vecmean of a positive number, and we do the positive number plus some other positive number, we only take a small step, then we should get the positive number should still be the small one. So, let's shorten this a little bit. Pnum is the new name. So pnum. Okay. So if we add a positive random number to a positive number, we get a larger one. So if we do vecmean on this, we should get back the positive number, the pnum. Okay, so now we can run 200. Posmin. Oh, okay. Pnum. I changed to pnum. Here we have it. So now we're running 2 test cases per loop, so we get 200 in there. They didn't report because they were in the loop, but if we run the whole thing, of course you wouldn't do it like this, like copy pasting, but I'm just doing that so that there are less things for me to explain to you. Now we get 209 passing and 1 well-known failing, so let's keep that out there. Where was it? Was it the positive one here? Let's take that out there so we don't have to. So we should go 209 passing one. Okay, very good. What more can we do? We can of course just change the order. That's kind of nice to test that, you know, it doesn't matter if we have another order. What more do we want to do? Well, I mean, maybe this is okay for the a little bit of random testing there. So that should be fine. Now we have 309 tests being made. They're all black box. So, okay, what can we do more with the length? We can do, of course, yeah, what would that be? I'm not sure. What is the implementation doing if I give it 0 length? Okay, so that's also a method error. Maybe I want to keep it like that for now. You know, this is maybe something I want to discuss with the developers if this is the correct thing. Right, so at this point I could go deeper, of course. I could take the right bicep and see if that would add something. Probably the right bicep and the correct sort of these heuristics that I talked about in the lecture, they would overlap a little bit with some of the ones I did here. There's of course a lot more you can do on sort of black box testing of this, but you saw here some kind of, I showed you like the basics. You start from positive cases like this, and you can of course go much deeper on that, but you start with the simple cases, the most used stuff, and then you think about corners, boundaries, strange stuff. We took very large values, small values to see if it behaves correctly, right? I mean, in Julia, for example, there's also, you can ask any type. So the type of floats is a float 64. There's a function called type max, which gives the maximum value of a type, and this is infinity, right? So we should try that. If we take, you know, or even here, if we take in random testing, call vecmin on the infinite float, a vector that has an infinite value at the start, and then it has a random positive number, then we should get pnum, because that is smaller than infinity, right? Oh yeah, of course. I didn't check that, so let's run the whole loop. I didn't randomize it here because that was in the loop. So we get a large one. And yeah, so that works well. You know, we can change the order in the random testing here to do pnum first, and then maybe pnum plus, you know, 5.6. It should still be pnum. And we can go like this. We can probably do type min for floats, right? The minimum value of the type float is minus infinity. So that is also useful, because then we would be able to say that vecmin on minus negative, so minus infinity is the smallest possible float. So if we call a vector with that in it, we should always get back the negative infinity, and that's always true. So now, you know, we could go on here and do random black box testing, and random just means that we introduce randomness. Of course, this is not a very smart random number generator, because it will mostly generate very large values, because there are more large values than there are small ones. So, you know, there are classical tricks for this, and probably tools would do this for you. But, you know, we could just take the logarithm or the 10 logarithm of the value, right? If you have a positive, so 10, to get the lowest number in the range, 1, you would take 10 to the power of 0. So this can give a 0, but it's very unlikely to give a 0 because then the random function must return the number 1, which is a very small part of this range. So if we take log 10 of a positive number, it's going to give us a positive number, right? Just, brushing up on it should give a 7, right? Yeah, so this only gives very small numbers now, so now we need to increase this, I don't know, 25. So let's do 25 instead, So this is not really a better random generator because now it's generating very small values. So that's maybe not great. So what we want to do is the opposite, right? We want to have, yeah, that's what we want to do. We want to generate random floats from 0 up to, I don't know, 10 to the power of to 20, right? And we're going to go much deeper here now because it's on the log scale. So give me a random number between 0 and 20, taken in very small increments. And then we're going to take 10 to the power of this random number because then now the range is on the log scale when we're randomizing. So now we get much more often we're going to get small values. So if we do this, okay, now we got a large one, but okay, mostly they are large, right? So if we go this down to 5, then they can be maximum 10 to 5, which is 100,000. So now we're getting also small values, which maybe is more interesting, right? We're getting smaller values, which is maybe more common. So now if we run this whole thing, it should still be true. Okay, so it's taking some time. I don't know why. Shouldn't take time. Maybe randomizes. Anyway, I've shown you random testing. I've shown you how you think about black box testing. You can run the whole thing, and we now have 610 test cases here. I mean, it's very simple test cases, but hopefully this gives you a sense. And I didn't show all the different ways you can think about, of course, when testing something black box. But as you saw, we didn't even look at the source code. So we don't really know what was going on, but we could do some testing. Of course, this testing is not perfect. We can go deeper on it, and then we're not going to catch all errors, but it's an example and a way to start, and hopefully you get a little bit more sense of how to do it. Thank you. I'll now conclude.